Welcome to the fourth and final video of Unit 5 about real-world machine learning. Today we're going to be talking about common software for machine learning. And before we start, this is by no means an exhaustive list of programs and options available out there. These are just some ones that I think are worth highlighting. So every day new libraries and machine learning opportunities are being developed. So this list will continue to grow, but for now I think it's important to highlight some of the primary ones that are being used in industry. So this is presented by EDU Onyx. Thanks for listening. I hope you get a lot out of this. So the first thing we're going to talk about is simply the top 4 programming languages for machine learning. Many experts would probably disagree with me, but the 4 that I believe, and this is again supported by usage data, Python is going to be the primary programming language used for machine learning. You also have Java, you have R and C++. Some notable languages also include C, JavaScript, Julia, MATLAB especially. Leaving MATLAB off this list was hard for me because I use MATLAB a lot, but not everybody does. Python is going to be used primarily for research type applications and research grade code. Python is open source and incredibly diverse. There are a lot of good libraries out there to do machine learning in Python. Different web applications and computer applications are going to be programmed in Java. Same with C++. These softwares run a little bit quicker. So packaged software or applications are going to be done in Java or C++. R is used in data science a lot because it's very good at statistical computing and graphing. So R gets used for those purposes as well. But let's dive into each one of these languages a little bit more and highlight some of the areas and libraries that they're used with. So the first one we're going to talk about is Python. Python, again, is an open source language used for scientific and numeric computing, software development, and much, much more. Some of the good libraries that Python does use, and the strength of Python is really in its libraries. There are so many different open source libraries that have been developed. The first one being the scikit-learn, and this builds on NumPy and SciPy by adding a set of algorithms for common machine learning and data mining tasks, including clustering, regression, and classification. There's also TensorFlow, which is another high-profile entry into machine learning, developed by Google as an open-source successor to Disbelief, their previous framework for training neural networks. TensorFlow uses a system of multi-layered nodes that allow you to quickly set up, train, and deploy artificial neural networks with large data sets. It's what allows Google to identify objects in photos or understand spoken words in its voice recognition app. We also have Theano, which again uses NumPy-like syntax to optimize and evaluate mathematical expressions. What sets Theano apart is that it takes advantage of the computer's GPU in order to make data-intensive calculations up to 100 times faster than CPU alone. Theano's speed makes it especially valuable for deep learning and other computational complex tasks. To be fair, TensorFlow is available to use with GPU as well, so Google has added that, and a great use for TensorFlow is that it has GPU capabilities. A notable mention would be Caffe, which is very similar to TensorFlow. It's another library that you can do deep learning in Python. If you remember our project in Unit 2, and I believe the Unit 3 project as well, we actually used the scikit-learn package when we were developing some of our machine learning algorithms in Python, based in IPython, which is the Jupyter Notebook application, of course. So we had multiple models. If you look down at the bottom here from the scikit-learn, we had both statistical analysis as well as different models imported directly from this machine learning library. So for most cases, scikit-learn is enough. If you're developing neural networks or deep learning models, then you're going to have to get into other things such as Theano or TensorFlow or Caffe. And here's this a little bit closely if you couldn't see before. All right, so we also have Java. And Java, of course, is a general purpose computer programming language. There are a lot of different libraries for Java, and we're not going to have time to go into all of them, but it would be nice to highlight some of the mains. Weka has a collection of machine learning algorithms for data mining tasks. The algorithms can either be applied directly to a dataset or called from your own Java code. Weka contains tools for data preprocessing, classification, regression, clustering, association rules, and visualization. The list goes on. We also have things like RapidMiner. We also have the ELKI, which is an open source data mining software written in Java. The MOA is a popular open source framework for data stream mining. A growing community using MOA. You also have Apache, which is a machine learning framework that contains a programming abstraction for distributed streaming machine learning algorithms, and this also enables development of new machine learning algorithms without directly dealing with the complexity of underlying distributed streaming processing engines. So that's very valuable as well. The list, though, goes on. We have JSAT. The Java ML is a Java API with a collection of machine learning algorithms implemented in Java. You have the MLlib, which of course is Spark, and this again is Apache's scalable machine learning library through Java. This is also supported in Python, ironically, although it does not get used as much. You have H2O, which is another machine learning API that's used commonly, and RankLib as a library of learning to rank algorithms. So Java, a lot of opportunities out there, gets used a lot if you're developing applications. R, primarily used in statistical analysis. R is a programming language and environment built for statistical computing and graphics. It provides a wide variety of statistical and graphical techniques such as linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, etc., etc. And again, R is free. It's great when the software can have all of these capabilities and is open source and free. So I've included a graphic here, which is the top 20 packages from the CRAN, which is the archival network for R. And I don't use these packages a lot in my own work and research, so I don't know as much about them, although you can see which ones come up more commonly in this graphic. In the last part here we have C++, and of course C++ is a general purpose programming language. It has imperative, object-oriented, and generic programming features, and it also provides facilities for low-level memory manipulation. Oftentimes, if you're working in Microsoft, you're using Visual Studio, which is coded in C++. And C++ is able to run at production level speeds, and so when you actually want to develop the applications, you end up using C++. Most software and applications are programmed in C++ today. In regards to the libraries, we have the MLPAC, and MLPAC is a machine learning library in C++ which emphasizes scalability, speed, and ease of use. And that really reflects C++ as a whole: scalability, speed, and ease of use. Initially, the MLPAC was produced by the FastLab at Georgia Tech. You also have Shark, and Shark is a C++ machine learning library that serves as a powerful toolbox for research as well as real-world applications. It depends on Boost and CMake, which come up in C++ a lot. You also have Shogun, which is a machine learning toolbox developed in 1999. And it can be used through a unified interface from multiple languages such as C++, Python, Octave, R, Java, C#, Ruby, the list goes on. So Shogun gets used for those purposes, and it also enables an easy combination of multiple data representations, algorithm classes, and general purpose tools. Alright, so we have kind of flown through these different languages, but ultimately the programming language you should use is dependent on your requirements and your preferences. Requirements and preferences is honestly on an equal standard here. So perhaps you know Python better, use Python. Perhaps you know R better, use R. If your requirements that it runs very fast, you're probably going to lean towards Java or C++. And your personal preferences are definitely important to consider when you're choosing the language that you use. If you like MATLAB, a lot of this can be done in MATLAB. Of course, MATLAB works so well with matrices, so if you want to look at the linear algebra or the underlying structure of these algorithms, MATLAB is a great route to go. Ultimately, it is up to you. The possibilities and libraries available out there are growing each and every day. So I hope one of these can be used by you for your application. In our projects, we've been looking at Python, and we've been using scikit-learn a lot, and we are actually going to keep going though, and we're going to develop in our final project a deep learning reinforcement algorithm. So it's going to be really exciting. It's going to use Jupyter, and it's going to use the OpenAI Gym, which is an exciting environment for machine learning gaming tasks. So we will get to that in the next unit. I hope you got a lot out of these videos on real-world machine learning. Sometimes we can learn about the differences between supervised and unsupervised learning and things like that, but how do we actually implement machine learning to our problem in industry is more complicated and a harder task. So I hope this has been beneficial and that you can successfully use Python, Java, C++, or whatever it is to build and develop an algorithm for your specific task. Thank you very much for listening.